Hey Opties! Today we're going to be talking about slope. We'll do some review of slope from a table, from 2 points, and a graph, and then we'll take a look at parallel and perpendicular slopes. First of all, we have our formula. Slope is m when we have equations, and if we're given 2 points, we can subtract our y values and divide by subtracting our x values. Now notice how it's y2 and x2, and those are vertically aligned, and the y1 and x1 are vertically aligned. This is because you're going from the same point when you start subtracting, and you're ending with the same point, and that has to be the case in order to find the correct slope. For graphs, we also think about this as rise over run, and kind of an all-encompassing way to talk about this is the change in y over the change in x, and that's what these little triangles mean, the change in, and they're called delta symbols. If we want to find the slope from a table, we just simply find the change in y over the change in x. So let's find what happens from our y's. So from 2 to 4, you add 2, and from 4 to 6, we add 2. Now let's look at the corresponding x values. From 1 to 2, we add 1, and from 2 to 3, we add 1. So now to finish out our slope, we just have to do our y change divided by our x change. Our y change is 2, and our x change is 1. And 2 divided by 1 is 2. So that is our slope, or our m. So we're done with that slope. Next, let's look at slope from 2 points. So this is very, very similar to looking at a table. And I also like to take my points and draw them where they are vertically aligned. So 1, 5 is our first point, and our second point is -2, 3. The reason I like to do this is because it's much easier to keep track of what point you're starting with and what point you're ending with. Another good way to do this is to mark your points as the first point or the second point. So we could mark this as the first point, and this one as the second. And to kind of go along with our y2 minus y1 divided by x2 minus x1, we can write our points as x1, y1, and x2, y2. So if you want to do it that way, then you can keep track of what's your first point and what's your second point. But it also works really well with vertically aligning them. So let's do it this way. If you're going from 5 to 3, you're going to subtract 2. And if you're going from 1 to -2, you're going to subtract 3. So then we do our change in y over change in x, which would be our -2 divided by -3. And finally, our slope is just +2/3. You could do the same thing using the y2 minus y1 over x2 minus x1 as well. Finally, let's look at slope from a graph. So we have a graph, and it shows us the vertical distance, which is our change in y, and our horizontal distance, which is our change in x, for these 2 points. Let's also just write out these points just to be sure. So this would be 0, 3, and the second point would be 1, 2, 3, 4, and we're going down 1, 2, 3, 4, so 4, 4. So if you wanted to, you could find the points and then kind of work it like you're working from 2 points, or you can actually use the graph. So let's do our change in y, because that's always our numerator. And then we'll find our change in x for our denominator. So the change in y is if you're at this 4y value, and you go all the way up to the 3y value, then you've traveled, and sorry, this should be a -4, then you've traveled 4 to get to this x-axis, then 3 more to get up to this other y value. So that's going to be 7. And you're going to have a +7 because you're starting at this point and going up. So if you're going up, you are getting towards more positive y values. If you're going down, then it would be a -7. And you could do it that way if you measured like this. And I'll show you why in just a moment. Now we've arrived at this point, we want to go left for our x change, and that's just going to be 4 because we're from this +4 to this 0, and that's a distance of 4. Now we've gone left though, so it's going to be a -4. So here's our slope. If we wanted to go off of the black dotted lines, we'd be going down 7, so it'd be a -7, and right 4, which would be a +4. So let's write it here. That's a +7 and a -4, or this could be a -7 and a +4. But notice they're the same. Either way, you're going to get -7/4, and you wouldn't have to put the negative out front. You could leave it on the 4 or the 7. Doesn't matter, but it just shows you that they're the same. Our point to ponder says, when finding slope, make sure you start with the same point for your x and y's. And that's exactly what I was saying earlier for our y2 minus y1 divided by x2 minus x1. Next, let's look at parallel and perpendicular slopes. So first of all, parallel slopes. Remember that lines that are parallel to each other are lines that never intersect. So they have the same tilt. And tilt is just a really general term for slope. So parallel lines have equal slopes. Let's see what our picture is here. And these are just two different representations of parallel lines. And again, we have equal slopes here. So if you look at these two different lines, you can visually tell that it looks like they have the same tilt, right? It doesn't look like they're ever going to intersect. They look parallel. But if you go about actually finding their slopes, you can tell for sure that they are parallel because they have the same slope. The slope is both 1. And we use that graphical method here to find those slopes. Okay, so perpendicular slopes are a little bit more involved. They're not just so simple as having equal slopes. They have what we call opposite reciprocal slopes. And here is an example of that. Opposite means you're going to change the sign. So if you're positive, you'll become negative. If you're negative, you'll become positive. Reciprocal means you're going to swap the location of numerator and denominator. So you have to have both of those things happening to have an opposite reciprocal. If you just change the sign, it's only opposite. If you just change the location of numerator and denominator, it's just a reciprocal. So it has to have both. A big source of error for people when they do perpendicular slopes is they only do a reciprocal and they forget the opposite portion, or vice versa. Let's look at our image here. So this decreasing line, it goes down 2 and right 3. So that's going to be a slope of -2/3. You could have also measured it this way, up 2, left 3. Same thing, it's going to be -2/3. If we look at this increasing line, we have a +6 and a right 4 for our rise over run. Or we could have our dotted lines like this, and it would be down 6, left 4. Either way, you get 6/4, which simplifies to 3/2. And notice, if you take 3/2 and you make it negative, it's going to be -3/2. Then, if you swap the location of numerator and denominator to make it a reciprocal, it's going to be 2 over -3, which is the same thing as -2/3. Because remember, your negative can be on the numerator, the denominator, or out front, and it will not matter. All right, Opties, that's it for slope and parallel and perpendicular slopes. See y'all next time.